Hi and welcome to another episode of McClutchy Maths. My name is Natalie McClutchy and today we're going to be doing a multi-part series on surface area. This is episode 1, looking at right prisms and pyramids. It's suitable for grade 9 and 10 under the Australian curriculum, grade 12 essential maths under unit 3 and year 11 general maths under unit 1. As always, I can be reached at mcclutchymaths@yahoo.com for any questions or concerns or anything you would like to request. So let's get started. So firstly, what is surface area? Surface area is the total area of all of the faces of a three-dimensional object. Total means sum, that implies that. And that's going to be that we're going to add up all of the areas of the faces of a three-dimensional object. There are many practical applications to surface area. You could be looking at painting an outdoor object like a water tank or a shed. You could be looking at how much rendering concrete you need to put on the surface area of a home. You could be looking at how much tin it requires to make a box or how much glass is required to make a fish tank. So lots of practical areas are involved. We're focusing today on right prisms. Right prisms include cubes, rectangular prisms, triangular prisms. One thing they all have in common is that they are three-dimensional figures that can have uniform cross-sections. That means if I was to chop it up, I could make equal pieces. Right prisms all contain a 90-degree right angle. You can see that in the cube, in the rectangular prism, and in the front face of the triangular prism. We're also looking at square-based pyramids, although I won't be doing any examples on these. They are fairly straightforward. The base of a square-based pyramid is obviously a square, and all the sides join at the top in a point to form what's called an apex, and here's the apex at the top of this pyramid. Now, I'm going to take you firstly through some common mistakes that students will make when they're calculating surface area. It might be worth pausing the video from time to time to take some notes of things that you need to watch out for. One of the first common mistakes I see from students is they don't read the question properly. Especially if they're given a diagram of a three-dimensional object, they automatically assume that they're going to be calculating volume. And you get no marks pretty much whatsoever for doing that. So also, I find students will make assumptions when they're calculating total surface area. For example, they might be looking at a right-angled triangle and assume that all three of the sides have the same length. Not always the case. They might assume that a shape is a square just because it looks like one. It might not be. It might be a rectangle. And that's why it's important to look for the little dashes on either side of the rectangle or square to indicate which sides are the same. They also make the assumption that an angle is a right angle just because it looks like one. If we don't see the little symbol showing that it's a 90-degree right angle, you can't assume that it is. Another common mistake students will make is they forget to include one of the faces. They might do a lovely diagram and draw a beautiful net of, for example, a triangular prism, but forget one of the faces, such as the base. That's a big issue. Alternatively, on the flip side of that, if you've got a practical problem, for example, a shed, like the one pictured below, where you're going to paint the outside, and that would include the roof and all of the walls, but it wouldn't include the floor because that's on the inside of the shed. So they would include that base. That would be a problem as well because you wouldn't need to paint that. So you need to think through those practical problems. Some other common mistakes students will use is to use the wrong units of measurement. They might do all of their working beautifully and actually calculate the surface area, but then give their units in cubes. So they might do cubic meters or cubic centimeters. We've got to remember this is surface area, so that means it needs to have squared units. Other students will put no units at all at the end, and that's also a problem. Marks lost. Also, some students have very confusing setting out. For example, they might do something like this. They've drawn the picture, they've labelled the different areas, and then they've jumped straight into doing a whole lot of working, but there's no actual explanation of what it is you're doing. We'd be far better if they'd actually written some formulas, if they'd actually had some words to explain what's happening here. So we've got number 1 is the front face. It's also the same size as the back face. So ideally I'd like to look at area 1 equals front and back face equals 4 times 3. Now you'll notice that they've actually made the mistake by doing that kind of working that they haven't remembered to add all the faces together. They've actually left out some faces. So we've actually got an incorrect answer. Notice the final answer doesn't have a statement. There's no units of measurement either. So it's very hard just looking at this student's working to even work out what on earth they've done. So make sure your setting out is excellent. And I'll take you through some worked examples to show you how to do that. Some other tips and tricks to use when doing surface area problems is to follow the Polya problem-solving process. Starting with C, read your question carefully, highlight and annotate any key information. So even if you're given a diagram, there is nothing to stop you doing things like writing on the diagram. For example, if there's information missing, you could add that to the diagram. If you need to make unit conversions, this is the time to do that. The next step would be to plan. You could draw a net. That could help some people to actually unpack the information in the three-dimensional drawing. Write those key formula down that you're going to need to use. So for example, in a right prism or a triangular prism, you're going to be using triangles and rectangles and squares. So you might write the formulas down for those in your planning stage. In the planning stage, you might also convert something. So sometimes you're given one side in millimeters and another side in centimeters. So you want to make sure you're calculating total surface area all in the 1 unit of measurement. And this is the time to do those conversions. You might also need to label your diagram with any missing information. For example, with the triangular prism, you might have a hypotenuse that you need to find using Pythagoras' theorem. This is the time to do that planning and put that information onto your diagram. Now you're ready to do the question. You're going to work through the question. You're going to use your words to explain your steps of working, and I'll show you that a little bit shortly. Also, when you come to the end, and that should say check, you're going to check, is your answer logical? Reread the question, did you miss anything? And then write a statement. So let's look at our key formula for right prisms and pyramids. And this might be a good time to pause and write them down. For a cube, we have our sides are all equal because all of the faces are squares. So you're going to have 6 faces, and it's basically going to be squaring all the sides. 6s squared. Rectangular prism, you've got 3 different dimensions there, a length, a width, and a height. And you're going to have 2 fronts to the box, a top and a bottom of the box, and 2 sides. And that's why our formula is 2LW plus 2WH plus 2LH. Then we have the triangular prism. Now in this particular diagram, I've also annotated it with a C. You can see the C over on the right hand side. That stands for our hypotenuse. And sometimes you might need to find that using Pythagoras' theorem. We actually need to know C to find that face that's sort of sitting on the side like that. That's a rectangular face there, and we need that hypotenuse of that triangular face to be able to work that whole area out. So our total surface area will be 2 times the front face, which is the triangle, half base height, that's the formula for area of a triangle, plus we've got the length times the base, that's one rectangle, plus we've got the length times the height, that's the back rectangle, and we've also got the length times the hypotenuse, and that's going to be that front angled particular rectangle that's there. We could simplify this a little bit further because 2 times a half is 1, so it's really the base and the times the height, plus the length times the base, plus the length times the height, plus the length times the hypotenuse of the triangle. And lastly, we have the square base pyramid. Now the total surface area for this, you've got your base, which is a square, so that's just simply going to be b squared, plus you've got 4 of these triangles meeting in an apex. And the formula for a triangle's area is half base times height. So 4 times a half gives us 2BH, and that's the simplified version of the square base pyramid's formula. So take a moment, pause, and write these formulae down. I'm going to take you through some worked examples now. In worked example 1, I need to find the total surface area of a cuboid freezer with a length of 2 meters. So I know it's going to be a cube, so I'm going to write my formula. Total surface area is 6s squared. I'm going to substitute the information in the question into the formula. Well, s, being the side length, is 2. So 6 times 2 squared. I can simplify this. 2 squared is 4, and then 6 times 4 is 24 meters squared. My final step is to check, have I got the right units? Have I written my units at all, which is very important. I want to make sure I'm not doing meters cubed here, because sometimes my brain gets tricked when I know that I've got a 3-dimensional figure. So I'm writing a statement, the freezer is 24 meters squared. Let's look at another worked example. In this particular case, I need to find how many square metres of glass are needed to construct the fish tank shown in this particular picture. Well, first of all, I'm going to do some planning. I can see that there's some information that would be useful for me to write on the diagram. I'm going to label each of the sides. I've got a width, a length, and a height. This will make it easier for me to substitute information into the formula. Now I write my formula. This is from a couple of slides ago. I'm going to substitute the information that I have into the formula. I'm going to take a moment just briefly to show you that 2 times the length, which is 3.2, times the width, which is 1.9, is substituted into that part of the formula, and so on across the line. Now I'm going to use my calculator just to simplify the 3 different parts. It's important you don't skip this step, or you could lose mark or half a mark of working. And then lastly, I'm going to add the 3 values together, and I come to 26.44 metres squared. And to finish off, I'm going to check my work, and then I'm going to write a statement. The fish tank requires 26.44 metres squared of glass. Once again, I'm checking I've used units of measurement and that I've got the right units of measurement. Let's look at worked example 3. Find the total surface area of this prism, it's a triangular prism this time, shown to the nearest square centimetre. Once again, I'm going to label my diagram and do a little bit of planning. So I've labelled the length, the base and the height, and once again this will make it easy for me to substitute into the formula, which I'm going to write down here, and this is the one I've taken from a few slides ago. Notice I've also got C on here, and you may need to label that yourself. That's your hypotenuse for that front facing triangle. I'm going to substitute that information into the formula, and once you've got this formula, it's very easy to do the substitutions, especially if you've labelled your diagram. Then I'm going to simplify this by using my calculator. I'm also writing this step of working in here because that way if I make a little mistake somewhere, my teacher can see where I've made that mistake. And I've been asked to do this to the nearest square centimetre, which is why it's always good to first of all show to a few decimal places and then show the rounded version. I'm going to check and write a statement. The prism is approximately 124 centimetres squared. This is where I'm also going to go back and check, because one thing I find students will often forget is to express their answer in the way it was required. And we are so used to doing everything to 2 decimal places or 1 decimal place, students will forget to round that to the nearest square centimetre and potentially lose another half a mark. This is our final example today, and the reason I've chosen this one is that there are some faces that are going to be excluded, and it's really important when you are looking at an example like this that you really think things through very deeply. So this is a picture of a barn. I'm going to be painting the walls and the roof of the barn. Now ordinarily this would be 2 shapes added together. It's a composite shape. I've got a rectangular prism on the bottom. I'm not going to be painting the floor of the outside of the shed, and I'm not going to be painting the inside of the ceiling of that rectangular prism. So there's 2 faces to be excluded here. I've also got a triangular prism stuck on the top, and I'm going to be painting the front faces of those triangles and the sides of the roof where it slopes, but once again not painting the inside of the ceiling. So I've got part of that formula that's missing there as well. So I can't necessarily just use the formulas I've memorized. I've got to unpack this a little bit before I get started. So firstly, I'm going to simplify this diagram and label it. You could try doing this by drawing a net. What I've done is I've actually broken it up into a number of different shapes. First of all, I've got the front and the back of the shed. I'm calling that area 1, and I've got 2 of those, so I've got in there times 2. And I've put the information that I've got straight from the original diagram. Then I've got the walls. These are the side walls that are made up of rectangles. I know that the height of those walls is 2 and the length is 4, and I've got 2 of them. The next shape that I need to add together is the front of the roof. It's a triangle shape. Now in this particular case, I've actually got to do some calculations to work out that the perpendicular height is that total height 3.5, take away the little square at the front wall of 2 meters, so that means that that perpendicular height of that triangle is going to be 1.5. And this is where doing this extra working to show what you're doing is important. Lastly, I've got the rectangle sides of the roof. They are 1.9, which is the length of that hypotenuse, and I've also got the length of the side, which is 4 meters. So I've labelled these different parts. I've got P for that perpendicular height of the triangle. I've got C being the hypotenuse. I've got B for the base of the barn. H for the height of the wall of the barn, and L for the length of the barn. Now I'm going to find the area of each section. So I've got area 1 is 2 times, because there's 2 of these faces, the base times the height, and so on. I've got 4 formulas there. If you need to, pause and have a look at how I've derived these formulas. In particular, area 3 is going to be 2, because there's 2 triangular faces, half the perpendicular height by the base. Now I substitute the information from my diagram into these formulas. And I've got 4 answers. Now, because this is a composite shape, I now need to add all of these surface areas together. So I'm going to be finding that composite area. It's going to be area 1 plus 2 plus 3 plus 4. And this is where using your words is important. This is why I broke that diagram up into 4 different areas and I called them different names. Notice here, it's not a lot of words. I don't have to write a story, but I've simply stated this is area 1, area 2, area 3, area 4. And now I've shown that I'm adding them together. And I've come up with a total surface area that needs to be painted of 44.4 metres squared. My last step is write that statement and check my work. Well, thank you so much for listening today. I hope this has been a helpful video. Make sure you take some notes and email me at mcclutchymass@yahoo.com if you have any questions or requests. Thank you for listening.